real question is, did I share the right thing? Yeah, I'm good. All right. So let's chat about regression, all that part 3 stuff. So I like to just do like a quick review of like the main big important points. Essentially, there are 2 types of questions that are the big 2 for the regression stuff. One is interpreting, and this is one that students tend to struggle with because when we're talking about interpretations, you almost have to like turn your brain off. And I know that sounds completely backwards for learning, but there are interpretations that are technically correct. We'll make sure that you are not, going off into bad places that you should have down. And the nice thing is you have lecture notes. I'm going to go ahead and upload this PDF. So you'll have this PDF to use as like a quick reference guide for the exam. So if you're asked to interpret, this means do not, please, 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 do not think on your own. Go somewhere to the lecture notes and find these straightforward interpretations. And there are 4 and 2 that I care a lot about that you're probably going to see on the exam. So the one that we see the most often is slope. And that's because it's one of the big takeaways of our regression line is being able to look at the slope and say, okay, here we know this particular thing. So let's say we had a equation for a line. So I'll just give this to us. And this is almost always given in our regression equations. So let's say we were given that we were trying to predict our final exam score. I'll put a hat on it, so it's obviously a prediction. And we were using some sort of pretest. So let's say I gave you guys the final exam at like the beginning to see what you already knew coming in. So let's say this is 54 plus 0.56 times that pretest score. And a good thing to mention here, which I was about to just blow past, is that for a lot of our interpretations and definitely for all of our calculations, it's a really important skill to be able to recognize which is our explanatory variable and which is our response variable. So I'll just do a little aside, figuring out which is X versus Y. What you're hoping for, of course, would be something lovely like what I've given you here. We always have this formula that's either in this, we typically do like B0 plus B1X, where we know that our Y is the variable that we're using as the output and our X is the input. So in this particular question, we would know our Y variable is the final exam and our X variable is the pretest. But sometimes I just give you the formula without that. And so the other way, obviously, if at some point, I'm probably going to tell you what the goal was. And so at some point, if I say we predict and we're trying to predict final exam score, that's me telling you that our final exam is our Y. There's also, of course, I could give you the actual scatter plot, and then you could see your X versus Y variables on that scatter plot. And then the last way, which I typically don't do on exams because you can make arguments a lot of times in either direction. And so I don't want to have students, coming up with a reasoning for something when technically either could be right, is generally we think of this as a directional relationship. We can't use that caused word unless we're doing an experiment, but thinking about our independent variable influencing a dependent variable. So if we have some relationship like that, that can help us, which we saw with the chirps versus temperature for the crickets. But again, not something I typically do on exams. So once you have all this work done, you can use the little fill in the blank sentence for slope. And I'll tell you how I grade this, even though you already know. So the fill in the blank sentence for slope is for every 1 unit of X increase in our X variable, our Y variable is predicted to, and then it's either increase or decrease by our slope units of Y. So I'll fill in what those different pieces are. So units of our X variable, Y variable, Increase or decrease is based on the sign of our slope. And then this is the slope itself, always as an absolute value because we already got the negative with the decrease. That's a common mistake on that first regression worksheet. And then our units of y. So this particular example, not the best, but it's kind of stuck in my brain because this is similar to the question I'm grading right now in the AP, is for every 1 point, they didn't give us units for this, increase on the pretest. And I guess I should have had score. Our final exam score is predicted to increase by 0.56 points. So that's the slope. That is probably the most common. You're going to, I mean, you will see this as a free response on the exam. You will do it twice on that regression worksheet if you haven't already, because again, this is one of the biggest takeaways of the regression line is this general relationship saying, all right, by looking at a pretest score, I know this much information, right? I can say what's going to happen point for point on that final exam. The other big interpretation that I like a lot is that correlation coefficient. Our correlation coefficient is just a lovely measure that we can use to describe that relationship between two variables. So it has this sort of quick and easy way to look at our relationship that's a lot more straightforward than our scatter plot. And so the correlation coefficient, which is our R, has to be given to you. And its interpretation is just there is a blank linear relationship. Oh, I can fit it between our X variable and our Y variable. Oops. And so the pieces that are going in here, the X and Y variables, in this case, it does not matter what order they are. If you actually look at the equation for the correlation coefficient, it involves multiplying z-scores, and that multiplication can happen either direction. So it doesn't matter if I put these in the wrong order, I'm not going to get in trouble. I'll put them in the right order. I'll be good. Pretest score and final exam score. And of course, we don't have one of these for this, so let's just make one up. Let's say our R was positive, because it needs to be positive because it always matches my slope, 0.6. So if this was my R, we would say there is a moderate positive. So your options here, they're on that in the lecture notes, but students tend to lose them because they're like way early, and then we get the formula for R later. It's either weak, moderate, or strong. And weak is basically close to 0, strong is close to 1, and moderate's anything close to 0.5. And then positive or negative are the two options for that direction. So the correlation coefficient itself tells us the strength and direction between our two quantitative variables. The other two interpretations, just to be completist, I will add them here, even though I don't ask about them too often. And that is our y-intercept for a of 0. And so this is whenever our x variable, so for an x variable of 0 units, because we're going to be good. So in our case, if someone got a pretest score of 0 points, our y-intercept tells us what we would think they would get out as a y. So we still need some important words. I didn't say it up here, but this is the one thing a lot of my old test keys are missing is that word predicted. I think it's in the y-intercept interpretation, but it needs to be in that slope interpretation, and some of my older exam keys don't have that language. It's just a -1, but worth noting. So for a pretest score of 1, we would predict, or the model would predict. I mean, there's obviously some wiggle room in these interpretations. In fact, you'll notice mine aren't the exact same between me talking off the cuff here and my lecture notes. But we would predict our y variable. So this is our y variable, our final exam score. I don't really know why I put R. That's awkward. We would predict final exam score to be, and then that's our y-intercept. And of course, the units of our y again. So y-intercept value and our units of our y. So in this case, I think it was a 54 points. So they could bomb that pretest and we could still expect them to end up with a 54 on the final exam to have learned something through the course. And then the last one, I guess I'll shove it in. I did not give myself a lot of space. Our R squared, that coefficient of determination. This is this R squared percent of the variability in our Y variable can be explained by the least squares regression. And again, I think this varies slightly from what I have in my notes, but this is not one I typically ask for. But the important piece to this is just recognizing more often what you're going to see in this particular question. Let me be good and actually square. So if I squared 0.6, I would have 36% of the variability in final exam score. The important thing here is really just knowing that when I talk about this variability explained, that is another way that I can mention R squared, which sometimes students will completely blank on what the heck that even means. And remember, R squared tells us about the strength and direction of our linear relationship. So one big chunk of points on the exam are these interpretations. So recognizing our interpretations for slope and correlation coefficient are likely ones that I'm going to ask you for right away, and to do as a like free response because they're nice and easy. You can just type them in without needing anything else. Whereas on some of my older exams, you might see them as multiple choice. But considering we have every resource at our fingertips, I expect us to be able to write these in a free response question. So the other set of questions from part 3, the other things that you need to know, and you get a ton of practice on these from the worksheet, are the actual calculations. Right? There's a bunch of stuff that we can get from our regression line. And so what I usually tell students to do for any of these calculation questions, it still matters greatly, which is X, which is Y in terms of our variables. But to break down each given number, if you can. And there's only 6 kinds of numeric things that could be floating around, 6 things you could be asked to calculate or be given to use in your calculations. That is X, Y, Y hat, E, R, and R squared. So just a quick little like, what are each of those things? X is the actual, and I'm going to make a distinction here between our X variable, which is like the pretest scores, and an X, which is an actual observed explanatory value. I guess I won't even put that. So like, but this is the thing. It's the actual value. So this is like one person's pretest score. So let's say I gave you a pretest score and your pretest score was a 50. That would be your X. Y is our actual observed Y for a particular individual or observation. So again, these two are actuals. They don't have hats. Our Y hat is our predicted outcome or response, our predicted Y. E is, oddly enough, our residual. This stands for our error. R is that correlation coefficient. And R squared is that coefficient of determination / percent of variability explained. So in terms of the calculations here, You are never going to be asked to calculate X. X is always going to be something that you're just given. I'm going to tell you what someone's pretest score. I'm going to tell you what the temperature was, whatever it might be. This will always be given. There's no work for you to do for that X. The most common question, or one you're definitely going to see, is y hat. Because when we first saw our regression line, and I'll bring back our example regression line again, our final exam score was 54 plus, I'm just making it up now, I don't remember, maybe it was 56 times that pretest. That was the other thing we did with our regression line. One was to talk about a general relationship. Okay, for every point you get on the pretest, we expect you to get 0.56 on the actual exam. But the other piece was this idea of using our regression line to make predictions. So to find these, all we're going to do is plug X into the regression line. The only way I can make this question more challenging, you'll see this on old exams, is that I will give you more information than you need. I'll give you X and Y. So if you don't take the time to break down which one's X and which one's Y, you may get that question wrong. Or if you don't pay close attention to what I'm asking you for, you might go one step too far. So if I tell you, for an example, we had a student scored a 50 on the pretest and a 70 on the final. What is their predicted final exam score? Students will get distracted here. Like one, they're like, but you just told me their actual exam score is 70. I'm like, yes, yes, yes. But what does the model predict? So just taking that time to be like, okay, this is my X. This is the actual Y. And we want a prediction. So we want a Y hat. Don't overthink it. I'm just going to go ahead, plug into this equation. And there's no reason to put the 70 where the Y is, because that's not Y, it's Y hat. And we'll just plug into this. And I could pretend I could do that math in my head, but I can't do it. Times 50. So this would be an 82. And we would be done. A lot of students would want to keep going because a lot of our examples on that regression worksheet have us go and find a residual. So don't do that. Stop as soon as you get to what you want. Don't go too far. But I had a really good question in the knowledge check of like, you constantly are talking about showing your work. How are we going to do that on an online exam? It'll either be a file upload question, or at the very end, the last question says, upload your work. So that way, if you went one step too many, I can at least give you points for knowing how to start this problem. The second question is either going to be usually one of these. I usually have a pool where you're either finding Y or E. E, as we just said, is the residual. I don't typically give this in a two-step question like I have in the notes. And you'll notice that you had two of these in that regression worksheet, and I did not write them as a two-step question. I made you do all the work. So it is a two-step question. Step one is to find Y hat by plugging X into the regression line. Step two is to use our residual formula. Our residual is Y minus Y hat. It's the actual minus the predicted. That's it. Same thing for Y, also a two-step process. If I ask you for that instead, I have to have given you E. And the step one is to find your Y hat by plugging into the line. Step two is still to use that formula, but you got to do a little algebra to get that Y alone. Or you can just rewrite this as Y is equal to E plus Y hat. You're there. One note about all of the values we just said you're going to have to calculate on the test. If you haven't already done that worksheet has a ton of rubric things where you just lose half a point for not putting units. So every single one of these has units, and they all have the units of our Y variable. So don't forget units on all of those values. The last two things I can have you calculate are not related to the line exactly. R and R squared, these are related to each other. So if we want to find R, we're going to take the square root of our r squared. 2 notes on this one. Remember, our sign should match the slope, because when we square a number, we lose whether it was positive or negative to begin with. So we got to go back and look and say, was it a negative or a positive relationship? And we also need to make sure we put our r squared in as a decimal, because our little r's are between -1 and 1. And if you give me on something that's not between those two values, you'll get in trouble. And then the r squared, same business, we're just going the other direction. So you'll take little r, wherever it is, square it. And then typically our r squared is given as a percentage. So those are the calculations that you are responsible for knowing. You are definitely going to see y hat. You're definitely going to see either y or e, one of those 2-step questions. So that's like 10 points right there. And then I'll usually ask on the other side of this, one of these 2 things. So again, probably in a question pool, you may see calculate r, your friend might see r squared. It really just luck of the draw, which of the 2 you get. So that's the like big points. If you just focused on these things, which is what that worksheet does, you would be fine. You would get a passing grade for everything part 3, which is the part that people struggle with the most. If you want to go just a little bit further, the last 2 things that I usually break down for part 3 are these differences between how we start the analysis and how we end the analysis. And so there's 2 pieces to this. At the beginning, we should run a scatter plot. That scatter plot allows us to look at our X and Y and tell 4 different things, right? So again, I could ask you to interpret a scatter plot as a free response. And the pieces we need here, D is direction, F is the form. All we really care about, is it linear? Can I do the stuff you learn in an intro stats class, or do I have to like go learn some more stuff because it's not linear? The strength, are the points close to whatever that trend line might be? And then are there any unusual features that we need to be chatting about? This could mean obvious grouping. Ooh, I can't spell. Obvious grouping, or an outlier, right? So an outlier might be something far off of our trend line, or like way over here. That is in contrast. So this is done at the beginning. And that is in contrast to our residual plot. And this is where students tend to struggle a little bit, is this difference between our scatter plot and the residual plot. Our residual plot, it takes those same points and it basically says, okay, if we fit a regression line to this, that regression line, anything that falls right on that, this is an, I almost put R, this is the residual of 0. Anything that falls directly on the line, perfect prediction, no error whatsoever. But so you can see like this last red dot here looks like it's pretty much directly on the line. So there would be a residual like directly on the line there. And everything else is going to have its points sort of away from the thing, just like we see. Residual plots are not always done as an X versus E, but that's typically how we see them in an intro class. But the important thing about residual plots is that we're actually looking to not see some stuff. These are done at the end of an analysis. And we don't want to see large values. The things that would be bad, I'll put them over here. Large values. And that is in terms of our E, because that means we had large errors. We don't want to see any sort of curve or pattern, because if there's a curve or a pattern, that means that we probably fit a line to something we shouldn't have fit a line to, or there's something else going on that we haven't really accounted for with our model. And then last thing we don't want to see is fanning, and that's when we see our residuals like doing a really close to the line and then getting away from the line as things go on. So we're basically looking for, we want random scatter. Whereas in our scatter plot, we're hoping to not see random scatter. We're hoping to see a nice linear relationship. We want to see a linear pattern because that means that we can proceed with our regression analysis, right? So like you do a scatter plot to say, can I do linear regression? Does fitting a line to this data make sense? Once you fit your line, you do a residual plot to say, all right, let's just make sure no violation, none of my things were violated when I did my line. Typically, if you're doing just simple linear regression, the scatter plot alone is enough. You don't really need the residual plot. But if you're doing something more complex, the residual plot can be very, very useful. And then this brings us to the other verses, and it's in the same sort of vein, and that is our correlation coefficient, our R, versus our coefficient of determination, which is our R squared. And again, this is sort of the same, it falls into the same boat in that it's all about, we're still talking about done at the beginning and done at the end. They are really two sides of the same coin. Just like the scatter plot and the residual plot have this like one-to-one relationship. Like I can pull any point out of my scatter plot and I could show you where it is on the residual plot. Same thing is true with our R and R squared. One is just a squared version of the other. They just tell a different story. So correlation coefficient, like I said, done at the beginning, tells us about the strength in the relationship, direction of our relationship. It just gives us a way to, I don't know, less subjectively talk about that scatter plot, right? The scatter plot, you can sit there like, I think it looks linear, I think it looks positive, and sometimes it's not super clear, but the correlation coefficient just boils it down to a single number, makes life a little bit easier. Whereas the coefficient of determination kind of, again, boils that residual plot down to a single number and tells us like, are our predictions any good? Because the bigger our R squared, the closer our predictions were to the actual values, closer the actual points were to that line, and we can say the predictive power of the model is better. We've done more to explain what's going on with the final exam score than we knew before looking at the pretest. So I think that's it. There's some other like little itty bitty things like the influential points and all that, which I don't tend to test on because it's just nitpicky stuff. But these are the main ideas. Like, do you understand the difference between these very related measures, very related displays? Can you do these calculations? And can you interpret? And again, interpret is very different than explain. Explain your reasoning is, I really want to see your thoughts. Make sure you've got me a conclusion, you've got me some evidence, you've linked them together, versus interpret is basically, I don't really want to see your thoughts. I kind of want to make sure that you understand the correct statistical language to use to talk about this particular thing. And best way to do that is to just fill in a sentence structure that's agreed upon by statisticians. And we don't agree on a whole lot of statisticians. So when there is an interpretation we can agree upon, life is good. So, yes, stop the